Hello everyone. So today we are going to continue with this robot like character, and today what we are going to look into is when the character moves in a uphill like this, you can see it's aligning with the slope of the ground. So this will be broken down into two parts, where in the first part I will be working on how to align the character along the direction character is moving, and next I will look into how to align the character across the character, so in the direction perpendicular, that means the roll of the character. So in this preview we have both pitch and roll aligned, but in this episode we will only figure out how to align the pitch. In the next episode I will look into how to align the roll. And this episode is sponsored by this generous patron. Thank you very much for the support. Right, so this is what we have at the moment. The character can walk like this, and it aligns to the rotation of the movement, direction of the movement. But when we go up on a surface like this, you can see the character is not aligning itself to the surface. So we are going to work on that today. And even if I work on this surface, you can see character stays, character remains horizontal. Right, so how can we fix it? Okay, so if you remember, last time we worked on this line trace to detect the surface location, and using the surface location we determined the target location. This means the location that character needs to move in order to align with the surface. We don't consider, we are assuming horizontal surface, horizontal plane like this flow. And as you can see here, surface location and target location is same because the root of the object is right here, so we don't have any issue with that. Therefore I'm gonna remove this part from here, and in the places where I have used target location, I'm gonna replace it with surface location. Right here also, because we don't need the target location for this purpose, and it works in the same way. Right, now the next challenge is how to align this character to the surface the character walks. So okay, so to do that, now we need to change the rotation of the character in order to align with the surface. Okay, so here we have the surface location, and so next I'm gonna use this target location. And by the target location, what I mean is, let's say the character is like this, and if the character wants to move into the direction shown by this red arrow, the target location is somewhere like this. Okay, so if we are on a non-horizontal plane, that if the character is here, target location might be somewhere over here in case of a character moving like this. Okay, so let's do another line trace by channel. No, wait, this has to be associated with the movement input as well. Right, so here for this start location would be same as before. the surface location plus we need to start doing the trace from somewhere in the middle of the character, maybe somewhere like this. So in order to get that, we can get actor up vector. Let's multiply it by, let's say, 100 units and add to this. So this gives some location in the middle of the character. Right, let me explain what I'm trying to do with an image. So here, let's say this is going to be the surface location, and actor up vector is like this. So if I add 100 units along the up vector, that means this is the next location we get from the result of this operation. The result of this operation is this point. Now if I add another vector along the controlled rotation, around the control rotations forward vector, that means let's say camera is here, and camera is looking like this. So if I add control rotations, if I add a vector 100 units in the direction of control rotations forward, that means I'm gonna get a point like this, where the distance between these two points gonna be 100. So on this point I'm gonna do another trace downwards, that means in the opposite direction of the actor's up vector. So by doing that, what I'm hoping to find is what is the next location this character will be moved into, and this is only valid if the character is moving using only W. If we are using A or D to move sideways, we have to do the same operation using the right vector generated using actor's control rotation, and do the same thing. I know it's not very clear, but let's try. That's what I'm trying to do here. So to this we need to add get control rotation and get forward vector, multiply it by 100 units and get another point. Right, now this is the point, this is this point. And also we need to multiply this with, we can actually select this. Now we can actually multiply this with the, I'll keep 100. We can multiply this with move forward axis value. Similarly, we can get right vector from the control rotation and do the same operation with multiply this with get move right axis, and we can add that also into here. Now that's the start location of the vector, start location of the line trace, and end location is at downwards, that means opposite direction of the up vector of the character. Let's say how much we have done here, 200 units, so let's try the same. Add another vector at we already have at up vector, multiply this by minus 200. Let's set the debug type for duration. Let's not do anything, just see how do we see the debug lines. Now as you can see here, you can see the red line. So yeah, that actually gives us the direction the character wants to move. See, it's always in front of the character when the character is moving. Right. Okay. Now here, if we have a hit, let's set a branch. That means we have a valid location where the character is trying to move. So we can break this, break the hit result, and using this location, so this is the location, this is this hit location, and if we do a operation, do a find look-at rotation operation from this point to this point, now that should be the character's rotation, that should give us the character's rotation. So find look-at rotation, start is surface location and end is target location. Oh no, end is the location, the hit location of this one. Now we can promote this one to a variable. Let's call it target rotation. Right, now if we don't have a valid hit, let's set target rotation as the current rotation of the character. So get actor rotation. Alright, now go back to the moment input part, and here we set the actor rotation. So let me break this and recombine. Then so what we do is we calculated the rotation character needs to have using this velocity, so I'm gonna get rid of that and use this target rotation instead of that. Right, now let me recombine this and directly connect to the set actor rotation. Right, now shall we test? Okay, so it does align as the character moves, and I think when we drop, right, it does work. Okay, oh wait, but it doesn't properly align it doesn't properly fix the relative role of the character. See, it only aligns itself properly along this forward of the character. Right, and also we have some bugs here. See, some odd things happen. Also, I think if we don't have a valid if we don't have enough if we don't have inputs, we should not do this. So I guess that's why this try to rotate back when we stop moving. See, okay, let's fix that. But before, we need to figure out how to align the role of the character. Align this way. How to do that? Right, so the jitter, glitching the character when we stop moving. I think it happens because when we don't have move forward or move right inputs, this surface location and the surface location and the target this trace end location becomes same, because these inputs become 0. So even though we have this one, so I guess we have, as the result, we have the same location as the surface location as the hit point. So let's add one more point and get actor forward. So let's multiply this with 50, so we can make sure that we have a different point than the surface location for this hit point. And let's add it here. Right, now let's check. Okay, it stops nicely now, even though I stop moving without trying to rotate. Let's try climbing the staircase. Yeah, great. Okay, right, now one more thing. You may notice, like when I try to move forward, you can see now the character is kind of submerged, and when I only release movement inputs, it moves up. So that happens, I think that happens because there is a flaw in the way I have implemented the movement input here. So we are giving the movement input completely based on the control rotation. Actually, not just control rotation, we use the surface location as well, but I think instead of doing it this way, we can use, let me replace this with the target rotation. It still has some issues, but anyway it works the same way. So I'm going to keep target location rotation instead of the control rotation here. Okay, right, so I'm gonna stop this episode right here, and in the next episode I'm gonna look into how to align the character's role as well, because here, as you can see, only the pitch is aligned but not the role. Oh wait, we have a small issue. When I press A and D, it moves like this, right? So I think we can't use the target rotation. We have to undo this part, right? Sorry about that. Let me check again. Yeah, it works as before, but we have that submerging issue that we need to look into, right? So let's continue with this system in the next episode and improve. And thanks for watching. So if you like to support my work, you can get the membership of the Bedroom Club. Link would be in the description below, and the project files will be available for the download. But I won't include this robot model as I don't have the rights to share it, but I will include the blueprint and all the calculations I have done, so you can check out the project and learn if you don't have any doubts from the video. Okay, thanks for watching and see you in another episode. Goodbye.